This lesson is on complex numbers, Chapter 1, Section 5. Open up your notebooks and your book to page 114, and we will get this lesson started. So complex numbers are often going to involve the imaginary unit I. Now, I means, or I is equal to the square root of -1. So now we are at that point where we are going to in fact deal with negative roots. Before, when they've happened, we've just discounted them because they are imaginary. So today's lesson is going to deal with that. So if I is equal to the square root of -1, I squared will equal -1 itself. Okay, if you take a root times itself, you guys already know that you get the number that's underneath the radical for your answer. So I is equal to the square root of -1, I squared is -1. The standard form of writing a complex number is a plus bi. Now, a is just going to be a constant. So if you have a number added to that I term, put the constant first. Then b is just going to be the imaginary part, and b is the coefficient in that part. So a plus bi is going to be the form that you need to have your answers listed in when you have complex terms. You can add and subtract complex numbers just like you can anything else. Like terms always combine, so if you have two terms with an I in them, they are considered like terms, and you can do the addition or subtraction. So for example, on this one that I have on the slide, we have two quantities that we're going to add together. In those quantities, we have 7 and 5 are like terms, so adding them together, we get 12. A 3i and a -4i are like terms, and you get -1i or -I there. Do have them written in this order. Remember, a plus bi is standard form. So 12 would be the a, and then -1i or -I is the bi term. Have that second. Watch the subtraction ones. Okay, so I threw this example in there just because we're really good at subtracting the first part of the second term, and then we kind of just forget about it on the second part. So here's a suggestion for you. When you have a subtraction of a quantity, maybe you want to deal with doing that subtraction or minus a minus and distributing your subtraction through that quantity first so that you don't miss those signs. Okay, now I can just combine my like terms. I do have a couple of constants, so 3 and -5 make -2. 4i and a positive 3i make a positive 7i. You can also multiply complex numbers. Keep in mind that I times I is a -1. If we're looking at this example now that I have on my slide, we have two binomials. We're still going to FOIL. Okay, so the first terms in each are 2 times 3. The outside ones, 2 times 3i, which is 6i. The inside, we have a -4i times 3, so -12i. And then the last ones, we have a -4i times, I'm going to use parentheses on this one, times 3i. Now the -4 times the -3 gives us -12, and then I times I, of course, is I squared. I squared, remember, is -1, so this is actually -12 times -1, or 12. Now simplifying, we're going to combine our like terms. Grab your constants first. We had a 6 and we had a 12, which give us a constant of 18. And then we have 6i and -12i, which go together to -6i. So there's our answer in standard form. We had talked back in our preview chapter about multiplying numbers by their conjugate. It was one way to get square roots or radicals out of a denominator of an expression. We also cannot or do not leave complex numbers or I terms in our denominators, so conjugates are going to help us with that as well. So if I had the expression 5 minus 2i, its conjugate is going to be 5 plus 2i. Okay, if we multiply those two together, again, they're binomials. You're going to have to use FOIL. We start with 5 times 5. Outside is a positive 10i. Inside is a negative 10i. And the last one's going to be a negative 4i squared. Now you can see how the inside outside are going to cancel each other out. 25. Now remember, I squared is negative 1. So you actually have a negative 4 times negative 1 back there, which is a positive 4. We would have gotten 29 for that answer. Okay, so if that had ended up being in a denominator of an expression and we had multiplied by the conjugate, our new denominator would have ended up being 29. So that leads into this one. The need to multiply a complex number by its conjugate will arise when a complex number appears in the denominator of a fraction or expression. You can't leave it there. Taking a look at this one, if we were asked to write this expression in standard form. Right now we have 2 plus I over 2 minus I. All right, that I cannot stay in the denominator of that term, so we need to figure out what we can do to it to get it out of there. Well, we're going to multiply by the conjugate. Now remember, whatever you do to the bottom of a fraction, you have to do to the top. So if I'm going to multiply here by 2 plus I have to multiply the top by 2 plus I. Foiling both top and bottom, we get 4 plus 2i plus 2i plus I squared. On bottom, we get 4 plus 2i minus 2i minus I squared. Okay, start simplifying. Up on top, I squared is negative 1. So putting my like terms together, my 4 and my negative 1 give me 3. 2i and 2i give me 4i. On the bottom, again, I squared is negative 1. So my negative 1 is a positive 1. My I terms cancel. So my denominator is 4 plus 1, or 5. Okay, I'm okay with you leaving this way. I would consider this written in standard form. You could also split it like this if that looks better for you or closer to what standard form shows. Both of those are the same. One rule of multiplying radicals does not apply to imaginary numbers. Okay, we've talked about multiplying square roots together, but there's one thing that you would expect maybe to be okay that is not. If you multiply two negative roots together, it does not make a positive root. You have to factor out the I and then continue to multiply. So for example, what I'm saying is if I had square root of negative 5 times the square root of negative 3, that is not the square root of 15. Okay, so on the next slide we'll go through an example and I'll show you how to do this correctly. Okay, but a negative root times a negative root does not turn to positive. That one rule does not apply. All right, so like the example says, root negative 14 times root negative 2 does not equal root 28. What do I do instead then? All right, well, the square root of negative 14 is the square root of 14 times the square root of negative 1. The square root of negative 1 is I. So square root 14i is a way to rewrite that first negative root up above. We can do the same thing with the negative 2. Okay, so the square root of negative 2 is the square root of 2 times the square root of negative 1. So square root of 2i would be another way to write that. Now we have a whole bunch of, we have 4 things to multiply together. The positive root 14 and the positive root 2 can be written together as positive root 28. And then I times I, of course, is I squared. We're still not quite done. I squared can be simplified. I squared is a negative 1. So the end simplified answer for this is negative 1 times the square root of 28, or you could just write it like this. Either of those are fine. Sometimes the solutions of our quadratic equations are going to be complex. Okay, so if we were asked to factor this trinomial, it doesn't take too long to look at it, figuring out you're not going to factor it the fast way with the two parentheses. So you're probably going to have to turn to something like completing the square, quadratic formula. There's a lead coefficient, so I would not go for completing the square as my next option. I'm going to put it into quadratic formula. Okay, so negative b plus or minus the square root of b squared, which is 196, minus 4 times a, which is 8, times c, which is 9, all over 2a, which would be 2 times 8, or 16. Start simplifying. Okay, so here you can see that in this next step, I'm going to end up with a negative 92 underneath my radical. Okay, so at that point, we need to start breaking some things. I'm going to break negative 92 into the square root of negative 1 times the square root of 92. And the square root of negative 1 is solvable. We get I. So now I'm at negative 14 plus or minus I times the square root of 92 all over 16. Now all I need to do is to see if the square root of 92 is simplifiable so that I can maybe do some reducing yet. And it does. It does break into a little bit. Square root of 4 times the square root of 23, and then the root 4 is solvable to 2. So now I'm here. I've got negative 14 plus or minus 2i root 23 all over 16. Now take a look at all of your constants in here. I have a negative 14, a 2. I can pull a 2 out of the top and divide that 2 out of the bottom. Ultimately, I'm going to end up then with this. Okay, so since I can factor a 2 out of the top, I can reduce top and bottom by 2. All right, I do have some problems that I want you to turn in to me by Monday. So if you're watching this like you're supposed to be, it's not due tomorrow, it's going to be due our next class day. I would like you to try the 8 that I have listed on this slide. Have them in to me by Monday. Obviously, you can be working on them in class as well, and we'll see how you can do with these complex numbers.